Hello everyone, welcome to Kriti Tutorials. Today we are back again with another important topic, that is Cramer's rule. We are going to study this table in a very simple way, right? So this rule is very important. We can see this rule is coming in ICSE board, state board, CBSE board, everywhere, right? In business maths, in applied maths, in mathematics. So here we are going to take up some conditions of Cramer's rule which are very important to understand, and we will be discussing the step-by-step solution as well. Now let's understand what does this rule mean. Now if we go with the name, some students ask, ma'am, what's the meaning of the name? So name is named after the mathematician who gave it. That's it. There is no relation to it with the method of solving. So Cramer's rule is one of the important methods applied to solve a system of equations. That's very important. So we are going to solve a given system of equations using Cramer's rule. So in this, the values of the variables in the system are to be calculated using determinants of matrices, right? So it is also known as determinant method. So one thing that we are going to use here is only the determinants, nothing else, right? So determinants of matrices is to be used here. So determinants, you all know how do we find the value. Here also we will explain you how to find the value, but it's a very simple topic left out once you know how to find the determinants. Now, one of the biggest advantage of the Cramer's rule is that it can be easily solved to find the unknown variables without the need to know about the other variables. We don't know any relation between the three variables, only the equations are giving you which are linking them together, and we can simply use this rule to find the values. Okay, so it's like that. So we are going to discuss the conditions and all. Now let's see the conditions, right? So conditions for the consistency, as you have the consistent system of equations in linear also, so same thing here also, whether the given system of equations is consistent or not. Now here I have written the word non-homogeneous. What does it mean? Non-homogeneous means that you have the constants also. X plus y plus z is equal to some constant. The standard form of non-homogeneous equation, if I write, it will be ax plus by plus cz is equal to d, right? Homogeneous कब होता है? When d is 0, then it is said to be a homogeneous system. So here we are considering non-homogeneous system of two linear equations, two equations and two unknowns. So of course two equations are there, so two unknowns will be there. If three equations are there, three unknowns will be there. So first we are considering two linear equations and two unknowns. Now what is d? D is the determinant value, which we'll be discussing it with the example and all. So if d is not equal to 0, the system is consistent and independent and has a unique solution given by x is equal to d1 by d and y is equal to d2 by d. Now if I take a simple thing here, ax plus by is equal to c suppose, and a1x plus b1y is equal to d suppose, right? So they are talking about a very simple thing here. What is d? D is going to be the determinant of the coefficients of x and y in both the equations. What is d1 here? D1 is the determinant formed by the constant terms and the coefficient of y. What is d2 here? D2 is a determinant formed by the coefficients of x and the constant term. This we will be taking it later on. Now let's understand the conditions first. So first thing that we have to check, see, all the three conditions are based on the value of d. That is the determinant formed by the coefficients of x and y. So if d is non-zero, of course it has unique solution. If d is 0 and either of d1 and d2 is non-zero, then system is inconsistent, it has no solution. So this is important for MCQs also. Please mark it on. This is important for MCQs also. Sometimes they give you such conditions, that is without solving you can check whether it's inconsistent or consistent. If d1, d2, and d all three are 0, then system is consistent and dependent and it has infinitely many solutions. So these three conditions are very important to analyze the given system of equations using Cramer's rule. Now let's understand what is d, d1 and d2 in detail and how to find the values of these variables x and y for two linear equations in two unknowns. Now, Cramer's rule for 2 by 2. So, Cramer's rule for 2 by 2 matrix is applied to solve the system of equations in two variables. Now, we have given you a system in two variables here. Now, let's understand what is D. So, D will be the determinant formed by the coefficients of x and y, as I said. So, here the coefficients of x and y are a1, B1 in the first equation. So we write it in the first row. A2, B2 in the second equation. So we write it in the second row. This is how do we mark it. This is R1 and this is R2. Correct? Now, what is D1? As I said, it will be the determinant of the constant term and the coefficient of y. So A1, A2 was the coefficient of x. So this A1, A2 will be replaced with C1, C2. And then B1, B2 will come as it is. This is your D1. That is, or in some books we will see dx because we are replacing the x variable with the constants. Now D2. Now, as I said, it will be the determinant of the constant term and the coefficients of x. So, first thing that will come here is coefficient of x, that is a1, a2, a1, a2. In place of b1, b2, what will you have? In place of b1 and b2, you will have c1 and c2. So, these three determinants we have here. D2 can also be written as d1. Okay, so that is what we told. So now you have to find d first. So after finding the d, that is, now those who don't know how to find the determinant value, let me tell you, it's very simple. It's just cross multiplication. First you have to multiply the numbers in the downward direction. So a1 b2 minus a2 b1. So it is nothing but up and down multiplication. So first down and then minus up. Down minus up, down minus up. That is what you have to do for 2 by 2, nothing else. Down minus up, cross multiplication. What will be d1? D1 will be c1 b2 minus c2 b1. Correct? Now what will be d2? D2 will be down minus up, a1 c2 minus a2 c1. Now these three determinant values we have to find. Now how to find x and y, which is our primarily the cause of doing all this, right? So now x will be what? D1 upon d or dx upon d. Y will be what? D2 upon d or you can say dy upon d. So that is what we were talking about. If d is 0, as you all can see, if denominator is 0 anytime, the values are undefined. So if d is 0 and d1 and d2 are non-zero, then they have no solution because if denominator is 0, we cannot move ahead because it makes it undefined. Now if d is 0, d1 and d2 are also 0, then it means that it has infinitely many solutions. That is, we can express x in terms of y or y in terms of x. And if d is non-zero, of course we can have a unique solution. So this was for 2 by 2. Now let me explain you the same thing with the help of an example. Correct? Now let's take a very simple equation, set of equations. 2x minus y is equal to 5 and x plus y is equal to 4. Now let's make d first. Now as I told you, d will be what? The coefficients of x and y. So first equation, what is the coefficient of x2? What is the coefficient of y? Minus 1. What is the coefficient of x in the next? 1. What is the coefficient of y in the next? 1. Now let's find the value of this d. Now as I said, down minus up. So what will it be? 2 plus 1, that is 3. Correct? So that's the value of d. Now let's move on to d1. As I said, d1 is the determinant which is formed by constant term and the coefficient of y. We will replace the x coefficients with the constant term and the coefficients of y. So what will be d1? Again, down minus up. So 5 plus 4, that's 9. Now let's find the d2. Now d2 will be what? The determinant of the coefficients of x and the constant term. So first the coefficient of x and then the constant term. Just replace the coefficients, remember, of x and y in order. That's very important thing here. Okay. Now what do you get here? 8 minus 5, that is 3. Now these are the values of d, d1 and d2. Now what is our formula for finding x? d1 upon d. So that is simply 9 by 3, that is 3. What will be y? d2 upon d. So that will be 3 upon 3, that is 1. So x and y are 1. And as we all know, we can easily check our answers also for the linear equations by substituting these values in the given. So let's do the verification also here. Now x is 3. Let's put x is 3 in the first equation. And y is 1 in the first equation. So what do you get? 6 minus 1, that's 5. And that is what the right hand side says. So it is correct. Now let's see if it satisfies that second equation. Also put in place of x3 in place of y1, and then you get 4, which also satisfies the right hand side. So our both the values are correct. You can easily cross check your answer also, whether we have done any mistake or something by chance. Otherwise, it's a very simple rule which can easily be applied. Okay, now let's move on to 3 by 3 now. Now we have to use Cramer's rule for finding the formula for 3 by 3 matrix, and therefore we have taken 3 sample equations for you. Now let's take it for D. It will be again the matrix of the coefficients of x, y, z now. And we have to find the determinants for the same. What will be D1 or dx? Replace the coefficients of x by the constant terms, and the rest will be the same, that is the coefficients of y and the coefficients of z. Now what will be d2? That is dy. So you are going to replace the coefficients of y with the constant term, rest will remain the same. So a1, a2, a3, and in place of y coefficients we have d1, d2, d3, and then c1, c2, c3. Now here one more will come, that is dz or d3, which will be the matrix for the coefficients of x and y and the constant terms. And we have to write the determinant for the same. So now a1, a2, a3, b1, b2, b3, and d1, d2, d3. Right? So these are d, d1, d2, and d3. Now how to find the values of x? X will be d1 upon d or dx upon d. Right? Now what will be y? Y will be dy upon d or d2 upon d. What will be z? Z will be d3 upon d or dz upon d. Again, the same thing applies. If d is 0, then the solution is no. Correct? That is no solution, no common solution for all the three systems taken together. If d is 0 and d1, d2, d3 are also 0, then it has infinitely many solutions. Okay, I just write it here. If d is 0 and d1, d2, d3, any of them is non-zero, then no solution. If all are 0, then we have infinitely many solutions. Infinitely many solutions. Right? This is what we have. And if it is non-zero D, then of course we have unique solution. Clear to all? Okay. So let's take the example for the 3 by 3. So now we have taken a system of equation. There are 3 equations and 3 variables if we check. Right? So let's make the 3 determinants here. So let's make D as the matrix of the coefficients. So determinant value for the same. So that is 1, 1, 1. So in the second equation, there is no x, so the coefficient will be 0 and 1 and 3. And in the third equation, if I write it in the standard form, I get x minus 2y plus z is equal to 0. So that is 1 minus 2 and 1. So that is the value of t. Right? Similarly, we will find dx, so which will be replacing the coefficients of x with constants. So that is 6, 11 and 0. And for the y, we have the same 1, 1 and minus 2. For z, we have the same 1, 3 and 1. Now for the dy, we are going to replace the coefficients of y with constant terms. Rest all will remain the same. So 1, we have 0 and then 1, then we have the constant 6, 11 and 0, then we have 1, 3 and 1. Right? For dz, we have to replace the coefficients of z with the constant term. So 1, 0, 1, 1, 1 and minus 2, 6, 11 and 0. Now we have to calculate the value of these four determinants. Now let's do the determinant for 3 by 3. Now let's check. Now for the determinant of D. Now let's do it column wise. Okay. Now 1. Now for 1 we leave the row and column in which 1 is present. Now 1 into down minus up. So that is 1 plus 6. Now for 0 we get 0. So no need to solve anything. Okay. So can just remove it also. You can just say plus 0. Then we have plus 1. Now leave the row and column in which 1 is there. So down minus up. So that gives you 3 minus 1. So 7 plus 2 is 9. So that is the value of D. Right, now let's find the value of dx. Now dx again we are going to do it along column 1. So 6. Leave the row and column in which 6 is there and down minus up. 1 plus 6. Now the next number is 11. Leave the row and column in which 11 is there and down minus up. And then the last is 0 already. So no need to do anything for the 0. So that's why we have chosen C1. So it makes our calculation on an easy note. So what do you get? 7 6 are 42. 42 minus 33. That gives you what? 9 simply. Correct? Now let's move on to dy. Now dy again we will do column 1. Okay. So because we have 0 in this, we can do column 2 also. We can do R3 just to make the calculation easier. If you are comfortable with R1, you can go with it. Now 1. Leave the row and column in which 1 is there. So 11 minus 0. 0 clear, nothing to write. So we will write only for 1. Leave the row and column in which the 1 is there. So you get 18 minus 11. So 11 plus 7. Okay, so you get 18. Now let's find the value of dz. Again we make it along the C1 because again we have 0 in C1, right? So again let's move on for the first element. Leave the row and column in which 1 is there. Down minus up. So what will you get? 1 into 22. Now for 0 nothing to write, right? You can leave it blank also. Now let's move it for the 1. Leave the row and column in which 1 is there. So again down minus up. So 11 minus 5. So what will you get? 22 minus, sorry, 11 minus 6, right? So 22 plus 5, that is 27. So these are the values for four determinants. Now we have to find x, y and z values. What will be x? Dx upon d. That is 9 upon 9, that's 1. What will be y? Y will be dy upon d. That is 18 upon 9. That is 2. What will be z? Z will be dz upon d. That is 27 upon 9, that's 3. Now let's check are these values correct or not. So let's substitute it in the first equation. So 1 plus 2 plus 3 is going to give you 6. So our value is correct. Right? We can substitute in the second also. Now your z is 3 and y is 2. So let's put it 2 plus 9. That gives you what? 11. Similarly, we can put in the third also. So now 3 plus 1 is equal to 4. So it also satisfies it. So our answers are correct. I repeat, x is 1, y is 2, and z is 3. Right? So this is what we have for 3 by 3. So there is nothing difference for the 2 and 3. Just we have to take care of the determinant value. Now let's take few word problems where mostly the students face the problem. Right? So word problems are also same as simultaneous linear equations. The only different part is first you have to frame the equations, and for that you have to take the let statement and then do it. Right? So now here the question is given here. A commodity was produced by using 3 units of labor and 2 units of capital, and the total cost is rupees 62. If the commodity had been produced by using 4 units of labor and 1 unit of capital, the cost is rupees 56. What is the cost per unit of labor and capital? So now first point is what is going to be x and y. So of course your x and y will be the cost per unit of labor and the cost per unit of capital. Correct? Now let's take the let statement. Let the cost per unit of labor, right? Let's take it is x. Clear? Let's make it more clearer now. So let the cost of capital now, per unit of capital. Okay, let it be 1. Now let's make the equations now. It's saying 3 units of labor and 2 units of capital is costing rupees 62. So 3x plus 2y is 62. Now the next line says the commodity had been produced by using 4 units of labor and 1 unit of capital. Then it is costing 56. So we have to find the cost per unit of labor and capital. And here we have written determinant method, which means Cramer's rule. Now let's make D. Right? So again, for framing the equations, you get 1, 1.5, depending on the questions carrying the mark. Right? So now D will be what? The matrix of the coefficients of x and y. What will be dx? Dx will be the matrix of the constant terms and the y coefficients. What will be dy? Dy will be the matrix of the x coefficients and the constant terms. Now let's do it down minus up. Remember, just down minus up. You will never land up with the wrong calculations. Right? So 3 minus 8, that is 5. Here we have the value of dx now. 62 minus 112. Right? So what will you get? 2, and here if we get 5, that is minus. Now you find dy, then again down minus up. 56 into 3, that makes it 168. 62 into 4. Now again if we subtract, we get minus. Just check everyone. Is it clear to all? We are getting all the values in negative, so don't worry, our cost will come out to be positive. Don't worry about it, we are getting the values in negative. Okay, so we are getting the values as minus 5, minus 50 and minus 80. Now let's use the formula. So x will be what? Dx upon d. So what is your dx? Minus 50 upon minus 5. That is 10. Right? What will be your y? Your y will be dy upon d. That is minus 80 upon minus 5. Minus minus cut out, so it becomes 16. Now you can check your answer always, as I said. So here also, if you substitute the values of x and y in the equation, it will be satisfied. So either you can check for both or one. So 4x plus y is 56. Let's take this first. And if I substitute x as 10 and y as 16, I will get what? 40 plus 16 is 56. If I do the same for the first equation, what will I get? In place of x, 10, so 30, and then 16 twos are 32, which makes it 62. So our values are correct. So your final statement will come out to be that the cost per unit of labor is rupees 10 and the cost per unit of capital is rupees 16. Right? So this is how do we go for word problems. Now let's take one word problem for the 3 by 3. Now try to understand what they are trying to say. Now a total of rupees 8,500 was invested in 3 interest earning accounts. The interest rates were 2%, 3% and 6% if the total simple interest for 1 year was rupees 380. And the amount invested at 6% was equal to the sum of the amounts of the other two accounts. Now how much was invested in each account, and we have to use Cramer's rule. Now, same type of questions we get in matrix method also and in the Cramer's rule, right? The only difference is how do we move on, but equations will be formed in the same way. So the question says how much was invested in each account. So let's say that let X rupees were invested in account 1, rupees invested in account A. Let's take ABC, okay? In account A. So that is be X. Let rupees invested in account B. Account B, that would be Y. Let rupees invested or amount invested in account C. Let it be Z. Okay. Now, correct. Now let's frame the equations. The first line says a total of 8,500 was invested in the 3 interest earning accounts. So what will be the first equation? The first equation will be x plus y plus z is 8,500. Right? Now the interest rates were 2%, 3% and 6%. And it was simple interest for 1 year and it was total
380 rupees. Now let's make it to that. 2% of X, 3% of Y plus 6% of Z. That makes up to how much? 380. Now you can remove these fractions by simply taking the LCM and taking the 100 to the other side. That will ease out your calculation. So we have just rewritten. This is first and this is second. Now the third says the amount invested at 6% was equal to the sum of the amounts in the other two accounts. So now 6% means Z, right? 6% वाला account कौन सा है? Z. That is C account. It is equal to what? X plus Y. So the amount invested in X and Y is equal to the sum invested in Z. So these are our three equations. Now let's find D, dx, dy and dz. Okay, now let's move on to that. So we have D. D will be the determinant for the coefficients of x, y and z. So let's make it very clear. 1, 1, 1, 2, 3, 6. Now if I write it, x plus y minus z is equal to 0. Okay, so that will be 1, 1 on 1 minus 1. Okay, so that will be 1, 1 and minus 1. That will be for the x, y and g. Now let's take it for the D. Now let's take it for dx. Dx will be the matrix for the coefficients of y and z and constant terms, and corresponding determinant we have to find. Correct? So let's make it for that. Now dx will be what? We are going to replace with the constants x coefficient. So 8,500, 38,000, 0, and here we get the rest 1, 3, 1, 1, 6, and minus 1. Okay, now we make up to the dy. Dy will be the matrix for the coefficients of x, constant terms, and the coefficient of z. Now here we make that corresponding determinant. So 1, 2, 1, 8,500, 38,000, 0, 1, 6, and minus 1. Now let's make it to dz. Dz will be what? 1, 2, 1, 1, 3, 1, 8,500, 38,000, and 0. Okay. Now let's again solve the three determinant values. Now let's solve it for the first. Now we take it according to the row 1 now, because there is no 0 here, so we'll take for 1. So now leave the row and column in which first element of the first row is there. So what do we get? 1 into minus 3 and minus 6. So that is minus 9. Okay. Now minus 1 for the next one. So down minus up. Again, leave the row and column in which the second one is there. So it comes out to be minus 2, minus 6. Now the third one. Leave the row and column in which the 1 is there. Correct? So it will be 2 minus 3. Now let's make it the solution. So that will come out minus 9. 6 minus 2, 8 plus 8, and then it comes out to be minus 1. So what's the answer? Minus 2. Correct. Check here everyone. Is it correct or not? Let me also check it once. Right. So 1, 9, minus 9, and then 8, and then minus 1. Correct. So we are getting minus 2. Now let's make up to dx. Now we can again choose first column because there is 1 0 over there. So it makes our calculations easier. Now let's make it to 8,500, and then minus 3, minus 6, and then we have minus 38,000. Leave the row and column in which 38,000 is there. So minus 1, minus 1. Now let's make the calculation. For 0, nothing will come. So for dx, what we are going to get? Minus 6 into 8,500. So minus 6, minus 9. 6 and 3 are there. So minus 9 into 8,500. That will make up to 76,500 minus 76,000. Right? So that comes out to be 500. This will be minus and this will be plus. Okay, so that will be minus 500. Correct. So that comes out minus 500. Now let's make up to dy. So dy, what we can do? Again, we can do it along any row or column, or you can choose the last row also for making your calculation, so that they will be easier for you. Let's choose r1 only here. So what we will get? 1 into minus 38,000, right? Minus 8,500 Leave the row and column in which it is there. So we get what? Minus 2 minus 6. And then 1, we get what? 38,000 minus. Okay. So now what will you get? 238,000 है हमारे पास. So minus 76,000. And then minus minus plus. What do we get here? 8,500 into 8. So let's make the calculations. 8,500 into 8. So we get here 76,008. 70,000. Okay. 68. Okay, 68,000. So that comes out to be minus 8,000. Okay. Now this is for dy. Let's find the value of dz. Okay. Now the determinant already we have written. Now let's solve the determinant value. So let's take it 1. We are solving it for the row 1. So 1, 3 zeros are 0, down minus up. So minus 38,000. Now for the 1, leave the row and column in which 1 is there. So what do we get? Minus 1. As we know, it goes alternate positive, negative in the determinants, right? So we get what? Minus 1 into 38,000, right? So minus minus plus it will be. Now what will you get here? For 8,500, leave the row and column in which 8,500 is there. So 8,500 into 2 minus 3. So this is what we are getting. Now let's take it out. So what will you get here? So we have here minus 38,000, right? Because it was down, minus up. So minus will come in. Now minus 38,000 plus 38,000 minus 8,500. So plus minus cancels out. So it's a simple number, minus 8,500. So this is the value of dz, dy and dx respectively. Minus 8,500, minus 8,000 and minus 500. Now we have to find the value of x, y and z. Now let's find the value of x, y and z here. So x will be what? Dx upon d. So which will be what? Minus 500 upon minus 2. That is come out to be 250 rupees. So the amount invested in the first account will be 250 rupees. Now what will be the account invested in the second amount? Right? So that will be dy upon d, that is what we were getting, minus 8,000 upon minus 2. So that comes out to be 4,000 rupees. And what will be z? Z will be dz upon d. That is minus 8,500 upon minus 2. That comes out to be 4,250. So these are the values of x, y and z. Now we can easily check our answer, as I have told you before also, by substituting them in the given equations that we have framed. So if we substitute x as 250, y as 4,000 and z as 4,250, I get 8,500, right? So we can say that our answers are correct. Let's verify with one more equation which is easy to solve. So z is x plus y. So that is also, we can see 4,500 is equal to 4,000 plus 250. So that you can do orally. No need to show. It is just to show that we are getting the correct answer. So I hope all of you would have understood it. If you have liked it, if you have understood it, please share and subscribe. Okay, thank you everyone.